cubic sequences. So the formula for a cubic sequence is going to look something like this. So you can have some numbers, some n's, some n squareds, and some n cubes. So the highest power now is going to be n cubed in our formula. Okay, so let's look at the two methods that we learnt last time. So the first method, method 1, if you remember what we did was we made a table look something like this. Now I've already kind of made the table for us to speed this up a bit. So basically, here is the general formula at the top. Now if you put n equals 1 into this formula, you will get a plus 1b plus 1 squared c, so 1c, plus 1 cubed d, so 1d. So we get this, a plus b plus c plus d. If you put 2 into this general formula, then we get a plus 2b plus 2 squared c's, well 2 squared is 4, so 4 c's, and 2 cubed d's, so 8 d's, and so on. If I put 3 into that formula, I'll get this. If I put 4 in, I'll get this. Now what I've done then is I have found the difference between the first and second terms by doing the second term minus the first term, and you end up with this thing, b plus 3c plus 7d. I've done the same from the second to the third to the fourth. So these are the first differences. Okay, now you can see they're all different, so it's not a linear situation. Now then I've worked out the second differences by looking at the differences between the differences, basically. So here you can see this is 2c plus 12d. If I do this one minus this one, I'll get 2c plus 12d. And this second difference is this. If you try it, you'll see. Now then, when I do the third differences, you can see that I'm going to get 6d. And if I'd have carried on my table, this would always be 6d. So the point about a cubic sequence is that always the third differences always give you the same number. So if the third differences are all the same, it's a cubic. If the second differences are all the same number, then it's a quadratic. And if the first differences are all the same number, then it's a linear formula. Okay, so what we're going to do is a similar thing to what we did last time. We're going to draw a line down here because it's easier to work out the ones that came before the first. It can help us a little bit. So it's the difference on the third level is always 6d, so that's 6d. So we can work back and see what this number would have been by doing 2c plus 12d minus 6d. That's 2c plus 6d. And if we do this, b plus 3c plus 7d minus this number to find that this one, the term before this one, then you'll see that it's actually b plus c plus d. And then finding this number is nice because if you do a plus b plus c plus d minus b plus c plus d, you actually end up with just a. Okay, so if you can remember these 4 things, then this method is quite good. If you have a good memory for remembering these things, if you can't remember these, then there's no point using this, because to make this table every time you do the question is going to kind of take you half the exam. Now in a way it's quite similar to the quadratic formula, because the quadratic one, if you remember, was a, b plus c, and 2c. So it's kind of similar, you just got these extra bits added on. Okay, let's do an example so you can see how this all works. So let's, I've got one here, 9, 23, 59, 129, 245, and 419. Okay, now if you work out the first differences by doing 23 take away 9, that's 14. 59 take away 23 is 36, and so on. I'll just fill in. These are the first differences. Okay, so the first differences are all different, so it's not linear. Let's look at the second differences. So this is actually 22, 34, 46, and 58. So all the second differences are different, so it's not a quadratic. But if we go to the third differences, we have 12, 12, 12. So it's definitely a cubic situation. Okay, so I'm going to draw my line down. And the things you've got to remember are these. So remember, the first one is A. The next one is B plus C plus D. 2C plus 6D. And 6D. But we have to work out the ones before the first one. So we have to work from the bottom. So obviously, second difference is always 12. Okay, now we work backwards. 22 take away 12, that's 10. 14 take away 10, 4. And then 9 take away 4 is 5, isn't it? So this automatically is telling us that A is 5. Let's write them down over here. So we already know the A. Now we have to work from the bottom to work out the D. Now can you see that 6D has to be 12? So D must be 2. Now, in the next line up, we have 2C plus 6D. Well, we already know that 6D is 12, or 6 times 2 is 12. So this is 12. Now you can see that C is going to have to be negative, isn't it? Because we have basically 2C plus 12 has to be 10. So if I take the 12 to do the side, 2C equals minus 2. So C is equal to minus 1. Okay. Now we work up to the next level. So we knew that C was 2, and we know D was 2, and C was minus 1. And these have to add together to make 4. So minus 1 plus 2, that's 1. So obviously B must have to be 3 to make this correct. So we now have our formula. So it's basically 5 plus 3n minus 1n squared plus 2n cubed, yeah, using the numbers from here that we found. And we could easily check that if we wanted to check it works, but it does. Okay, so this method is quite good because it's easy to work out these red numbers by just working backwards. But you do have to remember this, okay? But like I said, if you remember the one for quadratic, which is this, 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 it's kind of not so bad. So this is a nice method, and in fact, when you see the other method, you might quite like this method actually, because the other one is kind of complicated. Okay, so let's have a look at method 2 now. Now I've copied the table. I'm going to use the same sequence. Okay, so the starting point is the same. We have to realize that 6D is this number, so it's telling us we know that D is 2 from the start. Okay. Now in this method, what we're going to do is the same as the other method 2. You copy the sequence down. Now, because we know that the formula D has D equals 2 in it, in other words, there's 2n cubes, we're going to work out 2n cubed. And because we know that's part of the formula, we're going to write this underneath and subtract it to see what's missing. So 2n cubed, well, 1 cubed is 1, so that's 2. 2 cubed is 8, so that's 16. 3 cubed is 27, so that's 54. 4 cubed is 64 times 2, 128. 5 cubed is 125, so that's 250. And 6 cubed is 216 times 2 is 432. So we're going to just subtract them to see what's still missing, basically. So this is 7. This is also 7 actually. This is 5. This is 1. Now this is -5. And this is -13. Okay. So it kind of looks strange that we have these two 7s, but that can happen. So what basically we're still missing this from our formula. Okay, so if we can work out the formula for this sequence, then we will have found it. So because we can just add on the formula from this bit. So now it turns into the quadratic thing that we did yesterday, because we're assuming that if we've got the n cubes right, what's missing will just be a quadratic. So you're going to have to carry on kind of with what we did yesterday for method 2 with these numbers. So again, what we would do is find the differences first. So that's 0, 2. Sorry, it's -2, isn't it? Because you do 5 take away 7. And this is -4, this is -6, and this is actually -8. Okay. So then we obviously these are all different numbers. We're going to have to go to the second difference. Now this is -2, -2, -2, -2. So that tells us that this red box one is a quadratic, which is what we were expecting. And we need to find the formula of this red box one. So now we do what we did yesterday. We have to remember that when you have a quadratic, the second difference is always equal to 2c. So 2c is equal to -2. So c is equal to -1. Okay. So we now know that our formula has -n squared in it. Okay. So I'm just going to kind of get rid of this thing we just did to give myself a bit more space, because that was just to work out that c was -1. So I'll write that over here. So we now know our formula has -n squared in it. So I now need to write that underneath this sequence. So this is -1, -4, -9, -16, -25, and -36. Okay. And of course, I'm trying to work out what's missing, so I need to subtract. Okay, we're going to get some horrible numbers here. So be careful here, because you've got 7 minus -1. That's 7 plus 1 is 8. So when you're taking away a negative number, you're adding, aren't you? So this is 11, 14, 17. What's that? -5 plus 25. That's actually 20, isn't it? And this is going to be 23, isn't it? Yeah, that seems to be working out. Now, of course, we're left with this sequence, which all the differences are 3. Okay, so we need to work out finally what this one is. Okay, so that we can find the missing bit of our formula. Now, hopefully you can see this is going up by 3, so the formula must have a 3n in it. And the number before the first is a 5, isn't it? So it has to be, the formula for this particular linear one has to be 3n plus 5. So now we kind of know that that if we add the different parts of our formula together, it's going to add up to the sequence we need. So we just basically add together all of these parts, and that's our answer. So it's un equals 2n cubed minus n squared plus 3n plus 5. So you can see it's the same answer we got last time. We just got it in a different order, but it is the same answer. So this method is quite good, but it can get a little bit confusing, I guess. But yeah, you still have to remember a few things. With the we had to remember the d is 2, for instance. Sorry, the 6d is 12. You know, the 6d is equal to the third difference, and we also had to remind ourselves that 2c was equal to the second difference of the quadratic we got. So it's kind of, yeah. So it's up to you which method you use. This method is good because it's nice, quick, easy, because you have to do the table for both methods anyway, and it's easy to generate these numbers. So if you have a good memory, you can just memorize this and it'll come out pretty much straight away.